Hello, everyone, and welcome to my lab. Are you ready to learn?
Yeah!
Are you ready to have some fun?
Yeah!
Well, let's get started then. In my lab, we do a lot of fun experiments, and we always obey the safety rules. I am sure you have noticed that I have my goggles on. It is the state law that when we do scientific experiments that we put our goggles on. And I'm a law-abiding citizen, so I have them on. But that's not the only reason I have them on. It's good practice. I also want you to notice that we have a fire extinguisher right here, ready to be used, just in case something goes out of control. We're not planning on anything going out of control, but we have it as a safety precaution. And I want you to see it because I'm going to now set it on the side here where you and I and everyone in my lab knows where it is, and we use it as it is needed. So when you came in, you noticed that we have a lot of different chemicals and equipment on the tabletop, and we also have some things up in the air. What do we have up in the air? How many balloons are there?
6.
And what color are they? So we have 6 balloons, and each one of them is red, yellow, and green? No, what are they? 2 are green, 2 are yellow, and 2 are red. What do you suppose we have in those balloons? You know why you say helium? Because you know from experience that helium is a gas lighter than air. And that's the key word, experience. We learn things not only to store them in our memory banks, but to use them. So that's a key word I want you to be thinking and using it as we go along, experience. Now, there are some gases that burn. For example, the gas that I'm using here is natural gas, is liquid propane. And natural gas is what I'm burning in this beaker burner. But in this torch, you see this long orange flame. And near the bottom, you see a blue tinge. Next time you look at the flame from a match or a candle, see if you can spot that blue tinge near the bottom. And think about why it's blue near the bottom and yellowish orange at the top. So one experiment that we're going to do now is to find out what's in these balloons by taking the torch that I have here and putting it to the balloons, and we'll see what happens. I see some of you are covering your ears. Why are you covering your ears? Because you know from experience there might be a loud sound energy. You know, combustion reactions release energy in the form of light, which is what we see with our eyes, and also in the form of heat, which I can feel because I'm close to it, but also sometimes in the form of sound. So here we go with the first experiment. Let's see what's in this balloon. This balloon popped. It had in it the gas helium, and helium is a gas that does not burn. So we relight the torch, and now we will do what we always do in science, repeat the experiment. So we go to the next balloon. What color is it? Green. So let's see what happens now. Did the same thing happen? Exactly the same thing? No. The first time the flame went out, but the second time it did not go out. Why is that? You can think and speculate about this, right? That's one thing I ask you to do, to think about what you're observing and try to make some sense out of it. So I'll tell you what I did. The first time I had the torch very close to the balloon. The second time it wasn't as close. All right, so you think about what you're observing, think about what I'm saying, and always, always enjoy the experiments as we do them safely. So I want you to sit back and relax now, because we're going to move to the next set of balloons. And you notice that this balloon has what color? Yellow. So let's see what happens now. Did that yellow balloon have in it helium? No. It had in it a gas we call hydrogen. Hydrogen is also lighter than gas, but it combines a lighter gas than helium. Hydrogen is a gas lighter than air. That's why the balloon was floating up. And hydrogen combines with oxygen in a combustion reaction. We call it an uncontrolled combustion reaction. This is a controlled combustion reaction. The balloon exploded. You know what we call uncontrolled combustion reactions? Explosions. Right? So, what do we always do in science? So we're going to repeat the experiment with the second yellow balloon, but we're going to do it in the dark. So with the lights down, please, all the way down. Let's see what happens now. Are you ready for this? Here we go. Did you see that ball of fire? Yeah. Did you see it better with the lights on or the lights out? So that's one thing we keep in mind. Whenever we do an experiment that releases energy in the form of light, we do it in the dark so we can observe it better. Now what I want you to do is watch the monitor, because we're going to show you in slow motion the very same last experiment. You won't hear any sound. There is that. You like that experiment, don't you? So do I. That's why I do these experiments. Well, you know, we have 2 more balloons, a whole lot of other experiments to do. What shall I do next? More balloons or other experiments? More balloons. Okay, say more balloons. All right. All right. I will do more balloons. But you and I always obey the safety rules, right? And you noticed as we moved from the green balloons to the yellow balloons, the intensity of the sound got louder. And what color are those balloons here? Red. So is that a hint of some sort that I'm giving you, right? So that's why I want you to protect your ears from damage by taking both fingers and putting them in your ear like this. I can't do the experiment and do this at the same time, so I'm going to use this for ear protection. I want everybody to protect their ears. If you can hear the sound of my voice, that means you don't have your ears well protected, all right? Here we go. You ready for this? The red balloon had in it a mixture of hydrogen and oxygen. You know, air is about 20% oxygen, and the yellow balloons combined with oxygen from the air, the hydrogen in the yellow balloons combined with oxygen from the air, we had that loud explosion. But we put in more oxygen, more than 20% inside the red balloon. So, what do we always do in science? All right, and you repeat the experiment also by covering your ears. And what we're going to do now is repeat this experiment in the dark. So with the lights down, you ready for this? You sure you're ready now? Here we go. Watch the monitor. See if we can look at it in slow motion. No sound again. Much faster reaction than the previous one, right? Because there was more oxygen in there to combine with the hydrogen. So we always play it safe, and we keep sources of ignition away from hydrogen and mixtures of hydrogen and oxygen. By the way, I want you to know, there are other ways by which hydrogen and oxygen can be combined together without causing an explosion. And that's what we do in science. We learn about the properties of these chemicals and how to handle them safely so we can use them for different purposes. So we've seen now the release of energy in the form of light, in the form of sound, also in the form of heat because I was close to it, right? And some of you in the front may have sensed the heat, right? Now I want you to pay close attention to what I have right here. I have a glass assembly with a funnel on top and a spiral glass going into a large beaker. I'm going to take two clear liquids. One is clear and colorless, and one is clear and blue. And I'm going to mix them together in this special spiral glass assembly in the dark. So with the lights down, please. All the way down, all the way down. Here we go. Right, with the lights up, please. This experiment shows us the release of energy in the form of light, but not in the form of heat. This is still at room temperature. This chemical reaction is called chemiluminescence. Can you say chemiluminescence? Chemiluminescence. Very good. I hope that before you go to sleep tonight, that you will learn how to spell chemiluminescence. It's very important that we learn new words and what they mean and learn how to spell them. So now what I want to do is reach into my back pocket. What do people keep in their back pockets? Usually a wallet, right? So I have a wallet, and what do you usually keep in a wallet? Money. What else? Credit cards. What else? Driver's license if you're old enough to have one, right? Okay, pictures. Some people have pictures. What I'm going to do is an experiment. Here's my wallet. I'm going to set it right here, and I'm going to do this experiment by lighting a candle first. So I take a match, and I strike it. I light the candle. Whoops. So this candle is lit. Let me light this other one, too. And I should do this quickly before I burn myself. So these are examples of controlled combustion reactions, right? You see that, right? And they're colorful candles. The wax is colorful. So what I'm going to do is reach into my wallet and take out a $10 bill. And I take this $10 bill, and I put it in the flame. And there it is. Did you see that? Was that too fast? I asked you to pay close attention, remember? And you know that was not a real $10 bill. That was a fake $10 bill. That was a phony $10 bill. It was actually flash paper. It was actually flash paper, and flash paper burns and doesn't leave any ash behind. And what do we always do in science? Repeat the experiment. So I'm going to take out what looks like a $10 bill, but it's not a $10 bill. Put it close to the flame, and there it is. Disappears into thin air. So that's what the magician does. And the magician knows a lot of science, but doesn't tell us everything. The magician, he or she, they don't tell us what the explanation is. So flash paper has been treated with chemicals so that when it burns, it doesn't leave any ash behind, as I told you before. So now I'm going to take a $20 bill, a real $20 bill, all right? And what do you think I'm going to do with it? The same experiment, right? Same experiment. But before I do that, I want to ask you, I'm holding a jar here, and what do I have in here? What does it look like? It looks like water. The way we describe this liquid is to say it's a clear and colorless liquid, which is what water is. So I'm going to take this $20 bill. I'm going to soak it in this clear and colorless liquid, and then I'm going to fish it out using these tongs. Let's see if I can reach for it in here. Yeah, there it is. I'm going to fish it out. You see it's dripping like any wet object would. And you know what I'm going to do next, right? I'm going to put it in the flame right here, right here. So there is the $20 bill on fire. You see the flame, don't you? But the $20 bill is still intact. So now I ask you, can this liquid be water?
No.
You know from experience that water doesn't burn under these conditions. I'll tell you what this liquid is. It's a mixture of something we call the rubbing alcohol and water. It's half and half, 50% isopropyl alcohol and water. We learned from this experiment that the burning temperature of the alcohol is lower than the burning temperature of the paper from which this $20 bill is made. This is a good $20 bill. Now I'll put it back in my wallet here. And of course, put it to some good use. I want you at this time to please welcome Lauren. Hi, Lauren. Are you ready for the experiment?
Well, I think I'm almost ready,
Yeah?
but maybe we forgot one thing first.
What's that?
We need to blow out those candles before we
well,
move on.
I can blow this out. Shall I just do it?
Yeah.
Okay. That was easy to do.
Well, that's a pretty boring way to blow out a candle. Pretty boring. Everybody can do that. Yeah. Do you think I can blow out the candle from here?
No way.
I bet I can.
Oh. She did. That was good.
All right. Well, now I'm going to move on to my planned experiment. And so what I've got here is a conductivity tester, which is kind of a fancy name, but what does it look like? A light bulb. So if I plug this in, you can see nothing happened with the light bulb, no light yet. And that's because we're missing something. We need something to connect these two probes that actually will conduct the electricity through the entire circuit. So do you think the countertop conducts electricity? No, you probably don't want your countertops to conduct electricity. That could be bad. What about the knife blade? Yeah, so that should do it. It lights it up really nicely.
That's very bright.
Yeah. But what we can really use this for is to test the conductivity of solutions. So here I have a beaker of water. And you can see that typical water doesn't do much. And just to prove to you, these are all water. So nothing exciting going on yet.
All right.
But what if I add salt? So this is your typical just kitchen salt. I'm just going to pour a little in. Stir it up to make sure it's nice and dissolved. Let's see what happens.
Whoa.
Cool. And that lights up because salt forms ions in solution, and those conduct electricity much like the metal does in the knife. So I'm going to rinse this off because you want to make sure that you don't contaminate between your experiments, right? And now what happens with sugar?
It dissolves also.
It does dissolve also.
Yeah.
Stir that up. And now, no, so sugar doesn't work at all.
No conductivity.
So let's try some other things. What about vinegar, like what you use to cook? Okay, well, maybe if we turn the lights down, we could see something more. Oh. All right. So we saw something. It was pretty weak, not nearly as bright as the salt, right? I have one more thing. So this is ammonia. We use it for cleaning sometimes. And we'll try this one now. All right, maybe with the lights down again. So that one, yeah. So that one was even dimmer. So what happens, do you think, if I mix one weak one and another weak one? Any predictions? Is it going to just be the same? That'd be boring. There.
Oh, that was very nice, Lauren.
Yeah. But now I have one more experiment I'd like to show you guys.
All right.
Maybe something a little bit flashier even.
Flashier than this?
Flashier than this.
All right, if you say so.
So I'm going to show you a very exothermic reaction, something that's going to produce a lot of light and heat. So here I have your typical flower pots from like Home Depot. And you can see inside there's kind of the sand stuff. And so that's an iron oxide, like the rust that forms on metal objects at home, and also aluminum.
What are you going to do with the experiment here or someplace
Well,
else?
so we have a second set of flower pots in here. We want to use this case because it's a little safer. And to get the reaction going, it needs a little bit of a spark. So I have a wand.
And you need...
And we're going to use the burner to light my wand. All right. Get the burner going.
What do you have down at the bottom there?
Well, to show you what it's produced, you can see we have a very, very hot chunk of metal.
That's not even red hot, it's white hot.
Yeah.
Yeah. Let's take a look in slow motion and see if we can see it a little differently. A lot of light given off, a lot of light given off. Well, thank you so much, Lauren.
Thank you.
And now I ask you to focus your attention on these plastic bottles that I have that have in them screws placed inside each. They're not touching on the inside. I want to show you what it looks like on the inside. It looks like this. So there are two screws. They're separated by a distance of about 1 centimeter. There's a cork on top, and at the bottom there's a clear and colorless liquid. And what I want to do is an experiment using something that gives off sparks. It's called a Tesla coil. A Tesla coil, when I push the button, you'll hear the sound, but you can't see the spark. Let me see if I can try to show you the spark here. Here it is. I'm going to grab this scoopula. I'm going to hold it real tight, and then, can you see the spark now jump? Okay. All right. So what I'm going to do is touch one of the screws and see if I can make the spark jump across the gap that separates the two screws. We'll see what happens. You ready for this? Here we go. All right, there's one. There's two. Ready for the next one? 3. You ready for this? You sure you're ready? All right, here we go. You've been a wonderful audience. Thank you for coming and sharing the joy of doing science with me in my laboratory. And I want you all to try doing scientific experiments. Remember, no matter what you do them safely, but also remember that science is fun. Thank you all very much. Thank you. Thank you. Thank you.